Hey guys, welcome back. This week we're going to add one more new topic. We're going to add how to reflect and rotate a matrix, and that involves taking a figure and moving it around on graph. So this week, just to give you a rundown right here, we're going to start on page 6 in the notes, so you can turn your packet to page 6. I'm going to make the video lecture right here. You're going to watch this. Then after we finish the lecture, if you don't remember how to multiply matrices on the calculator, this is exactly what you need to rewatch, multiplying matrices on the calculator, because all this new topic is multiplying matrices and making matrices. And then I'm going to walk you through, and you're going to do page 16 and 17. So the lecture's short. You want to go to page 6 again of the notes, and this is our first slide. So this is on page 6 of the notes. And what we're going to do is we are going to use matrices to move shapes. Not a lot of slides here at all. So it's called graphic transformations. And I want to explain to you what's happening here. For all of this week, you're going to envision you have a shape. And that shape is made up of points. So if I had graph paper right here, X and Y, this shape would have point A at 0, 0. So that would be my point A. Point B would be at 6, 2. So you'd go out to 6, 1, 2, 3, 4, 5, 6. And then you'd go out 1, 2, 6, 2 would be my point B. We're going to make a shape now with another coordinate at 8, 6. So we are at 6, 7, 8. 1, 2, 3, 4, 5, 6. So my third point right there is point C. And then D is at 2, 4. 1, 2, 4. And that's D. Now, here's how the shape works. You go A to B to C to D, and then back to A. So we make this kite-looking figure. Now the idea here is we are going to use matrices to show the points of a figure, and once we have the points here, X is in the top row, Y is in the bottom row, we can take this figure and we can transform it, meaning move it, change it, and you can do it all with the calculator with very little thinking involved because the calculator does the work. So we're going to use this figure A, B, C, D, except we're going to use the matrix for it. So point A is 0, 0, top down, not left, right. 0, 0, 6, 2, 8, 6, 2, 4. And we're going to change this picture around. Let me show you. So we take that same matrix, and on this slide, what we are doing is we are going to multiply it by a scalar. This is basically called the dilation of the figure. Not a big word, not important. But what we are truly doing here on the figure is we are, for instance here, doubling its size. So if I take 0, 0, 6, 2, 8, 6, 2, 4, and multiply each one of those numbers by 2, and here 3, and here 4, what I'm doing to the graph is I am changing the size of the picture. It's the same exact shape. It's just getting 2 times bigger, 3 times bigger, and 4 times bigger. So I'm going to stop the lecture real quick. I'm going to show you what you are doing on page 16 today. On page 16, you can see it has a very similar figure. What you are going to do on page 16 is take this figure and you are going to dilate it just like the slide showed with 2 and 3. So the first thing you're going to want to do is take and make a matrix out of the points. Remember, A will be 0, 0, and B will be 4, 2. And then you will figure out how to put C and D in there. And then what you will do is you will take this matrix here, and you will multiply the entire matrix by 2, and then over here the entire matrix by 3. Now, one secret here for this page 16 is that when you are going to graph these figures, The idea here for perfect success is to put 0, 0 in the bottom left corner. So make 0, 0, point A. This is 0, 0, make that. And then only use this to go right. For instance, make this point 1, then 2, then 3. Make this 1 and 2 and 3. And what you'll notice is you'll be able to put the shapes all easily on the paper if you follow that 0, 0 goes in the bottom left. So this is called, again, dilations. You take points, you put them into a matrix. You could take that whole matrix and multiply it by a number to make it a figure twice as big, 3 times as big. You can use a half and make it half as big. But that's dilations. That's our first transformation. The second transformation, which I go back to the slides here, is to reflect a matrix or reflect a figure. If you look here, if the blue figure was my original and I reflect it in the x-axis, that means reflect over the x-axis. What you're doing is you're taking the blue picture and you are flipping it on down. You are flipping it on down. And if you take here, you reflect over the y-axis, you're reflecting it left to right, meaning over that y-axis there. And the way to do that is you don't have to memorize these matrices. They're going to be on a reference sheet for you at all times. But what you do is you take all of the points and you take the points of whatever this figure is. I don't think this, yeah, it's not working right now. You take whatever this figure is, that's why. We take whatever this figure is, and you take the points, and what you do is you multiply them. So, for instance, right here, if I took this point, and let's say this point was 4, 2, then I would make the matrix. This would be point B, it'd be 4, 2. Let's say this point is 1, 2, and then this point is 1, 4. I could take this matrix right there, multiply it by the points on this figure, and you would get our new figure down here. I'm going to show you how this works, but we're going to start today, which is x reflections and y reflections. So here is an example of how it works. Now, what you will notice here is I gave you the original coordinates. You might not always get the original coordinates. You might be making these yourselves. So to think about it, what this is the picture we looked at before. This is, let me get a better pen here. This is 0, 0. That was our point A. B was at 6, 2. Our B. Our C was at 8, 6. And our D was at 4, 2. So this was our original picture. And then what you see is I left multiplied by the x reflection. So what this did was reflect over the x-axis. So it took this picture and it reflected it down. Look at these new y coordinates. See, the y coordinates went from positive to negative. So it took this picture and flipped it down under here. It flipped it over the x-axis. That's what we're doing today. We're flipping over the x-axis by multiplying by 1, 0, 0, negative 1 on the left side of the points. Or we are multiplying by negative 1, 0, 0, 1 to reflect over the y-axis. So again, to show you what this does to the points, is this takes our original figure and it takes the y-axis and it flips it over that axis. So it flipped it over that axis, that y-axis. Now, the last thing I'm going to stress, is if you want to reflect over the y-axis or x-axis or anything, the points matrix of the figure, like the points x, y, x, y, x, y, x, y, is the second matrix. The first matrix, matrix 1, because remember multiplication order matters. This always has to be the matrix that comes first. So if I want to reflect over the y, the first matrix is the y matrix. You can't do it in reverse. Now, I'm going to stop here, and I'm going to help you with page 17 a little bit, because this is where your classwork ends today, page 17. So we just looked at page 16 in the notes packet, and now we're going to look at how to do page 17. You will see here, I have number 2. We're going to do it together. This says first you want to multiply by the x. Well, you don't have to remember these because, let me pull it up for you. If you look at page 18 of your notes packet, let me pull up what page 18. I'm going to pull up, if I have it here, what page 18 of the notes packet looks like. Might not have it. Here we go, page 18. This is page 18. This is your reference sheet for these. What we are looking at a lot is right here. If you want to reflect over x, I take this matrix. I want to reflect over y, I take this matrix. So you take the right matrix. So here are the rules of the procedure. Take the correct matrix. For question 1 or 2 here on page 17, I want the x matrix. So I look for the x matrix. 1, 0, 0, negative 1. And I write it out. What do I do again here? All right, here we go. I take the matrix 1, 0, 0, negative 1. That's the x matrix. Then I take the figure matrix. Well, I don't know the figure matrix. I'm going to have to make it myself. So point A is at 1, 2, negative 1, negative 2. So this is 2, negative 2. So I'm going to do 2, negative 2. Point B is at 1, 2, 3, 4, 4, 4, 4. Point C is at 1, 2, 3, 4, 5, 6, 6, 1. Now, what I want to do is I want to multiply these two matrices together in my calculator. So you would put this as your matrix A in the calculator, and this is matrix B, and you would multiply them together. And that would become 2, 4, 6, 2, negative 4, negative 1. And then my new figure would be graphed. So I would go to 2, 2. That's my new point A. 4, negative 4 is my new point B. And 6, negative 1 is my new point C. And now you can see I have my answers. I have my new figure. You can see it was reflected over the x. That was question 2. You are going to do that for question 3 and 4. Then you will turn in to me today pages 16 and 17. And that will be today's classwork. Now, for next class, I want to show you all we're going to do is change one thing. On page 18, you will see that below the reflection matrices, this one and this one, is the rotation. See, rotate matrices. Basically the same, just with the negatives and the ones in different spots. For next class, you're going to use these 4 matrices right there, page 18 again, page 18. I will put that on my website. And for 18, you're going to take matrices or pictures, and you're going to rotate them by the degrees it says. For instance, here for 90, you would have to take these points. You would have to put them into a matrix. You would have to put them into a matrix. Let me show you what I mean. For the later ones, it's easier. So I put D, E, F, G into a matrix like negative 3, 1, Then I have E, negative 5, 1. D, E, F, negative 6, 4. Negative 2, 4. I have that. And I want to rotate this by 90. So on the left side, always the left side, I put my 90-degree rotation matrix. I don't have it memorized. I'm looking it up right now just like you would look it up. For 90 degrees, it's 0, negative 1, 1, 0. I will put 0, negative 1, 1, 0. I would multiply these in my calculator, and the answer is the new figure. That's what you're going to do on this whole page. This will be next class. This is pages 19 and 20. 19 and 20 will be next class's assignment. And for now, 19 and 20 next class's assignment. You're going to use page 18. You're going to use this lecture, and you are going to complete pages 16 through 17. That's all for now.